So yeah, should we go ahead then? Time has started. Welcome, Bjørn. Yeah, my name is Jakob Gottlieb Sve, and I've been here quite some years at the conference speaking. You might have seen me before in shows such as Mr. Brick falling off the table or other things, or maybe late night asking when I would go to bed. But I've changed jobs since last time, and I'm going to speak today about managing Azure at a leading capital markets fintech. Such an easy title, right? I asked my CTO, can you come up with a fluffy, pop title for our company when we can't say the name of the company? And this is it. But actually, I am allowed to say the name. I just missed one thing here, because I work at a bank called Saxo Bank in Denmark. Yeah, but let's go ahead and thank you to the sponsors. They're all great. This is me. I'm Chief Cloud Engineer. So what I do is to kind of figure out the tech-wise on the Azure-specific parts. So I'm not the Kubernetes master or enterprise architect, but what I do is to figure out and solve challenges we have. And also my team, we improve the experience for the developers. So I'm technical product owner of the team called Cloud Foundation, which the technical word is great for me because it means I have no responsibility for people, because that's not a thing I'm so good at. But I'm super good at technical stuff, so that's why I'm there. But I have been consultant for many years. So last time I was here, I was consultant. And it's a funny, quote, funny change to move from consultancy to enterprise. You kind of realize as a consultant, you're a guest, right? So you come with your super nice product and you build it, but there are things internally happening that sometimes is a bit more cumbersome, which I never realized in many of the projects as a consultant. I have this jakobsvendsen.com page, which is my blog with a few blogs. Mostly if I find some weird, quirky thing that I can't find any help on Google, and I solve it, and then I put it there so that it's on Google. That's mostly the reason. Okay, so what are we going to speak about today? We're going to speak about managing Azure. And it means we have a lot of rules in the bank. First one, why? I usually compare this with if you select, at least if I try to attract new team members and all that, the thing that gets me going with this job is that, and the bank, is that if you ever played a game of Doom and you select level easy, right, and you shoot all the bastards, and then it stops, and then you're done, and you had a fun 10 minutes or 1 hour. You can also select level hard, and you practice, and you try to become really good. You spend days and days, you have so much entertainment, and then you succeed, and then it's an amazing, you pop the champagne and everything. So the same here, of course, it's also super frustrating sometimes. But it is level hard because we have a lot of things to follow. So we're going to talk about what challenges does it create now that we have all these, which I'm going to explain all the rules, or not all of them, we only have half an hour, and then how. And this is going to be a special PS version, which means that I have cut down around 80% of my slides, and I've created a PowerShell-based example instead. Which you can use, which I'm going to show kind of the base stuff. So I'll try not to spend too much time on intro, but I'm notoriously bad at not spending too much time on intro. In Saxo Bank, we run in Azure. We don't run any other clouds. We have, of course, on-prem, and we're also looking into like on-prem cloud, or at least Kubernetes, Azure Arc maybe, Azure Stack HCI, and so on. But we do run Kubernetes service as our main platform. And in the future, very soon, a new platform is going to come up, and we're going to run it via Flux GitOps, the way we deploy. This is not what I'm going to talk about today, because what I do and what we do in Azure is also to make sure that all of the rules in Azure are correct, right? And this is nothing to do with Kubernetes, but Kubernetes also runs in Azure. We run dynamic test environments. It's kind of a copy of our on-prem test environment. Now you can just order one for yourself, which means we redeploy around 1,000 to 2,000 virtual machines at least once a week, because they reset every Sunday, and then they have new many gigabytes of dummy data injected and so on, so forth. So every Monday they have a new, fresh copy that is the same state as the production. And it's because we have been doing this fintech stuff for 20 years, so most of our stuff is still on Windows servers. Most of it is on-prem still. We do run an express route to Azure, 10 gigabit, and we now have what's called the reference architecture made so that any kind of new app that is being developed, especially things for customers, they have to follow that reference, or they should. It's not a requirement for everything, but they should follow the enterprise architecture, because then we can run it in Azure, on premises, maybe other clouds in the future, I don't know. Yeah, but what are we talking about today? We're talking about risk and regulations, the most funny thing ever. We are a global bank, so we need to comply to many regulations, even more than I would think existed before I started, right? We have SOC 2, SOC 2 Plus, which is quite high level of that. We have what's called the Cloud Security Alliance, but there are also other things, such as Singapore government has a really strict rules. It's over SOC 2 Plus, but they're really in front, trailblazers on setting cloud rules, so we need to follow everything in all countries we are in. So it's kind of a mix of all this. And how do we do that? Well, how many here use, first of all, when we release stuff, how many here use change management? Okay. We have all production changes go through a CAP board, change approval board. I'm not going to spend too much time here, but it meets in our company twice a day. So India time, that's 9 a.m. in the morning, that's afternoon in India, and then around 14 in Danish time. This is where if you make a change, it has to be approved there before it gets released. You'll see in my pipelines that, in an example, that we actually automate that part too. But there are still this manual approval and just there, and you can be invited to explain if they don't know what you're talking about, or if you know already it's a new thing, you might want to join the meeting and explain what you're doing. But the problem with change management is that you have to wait for CAP. And I said we have automated it, so it also means that in some cases, if your pipeline fails, you have to wait for the next CAP. And if you know about pipelines, there can be many, many different errors. So sometimes you can end in some loop, and that takes, 5 CAP boards before you have something deployed. That is then maybe 5 days, or maybe half if you actually manage to send it in before. So we do something called low-risk CAP. We have made a set of rules that say if your code and all you develop follow these rules, and the rules are what's called trunk-based development, means you have very short-lived branches. A branch that you make only has a little piece of functionality in it, and you have to try to keep it to only 1 day. That's not specific, but that's what you would try to aim for. You have unit testing, so it's covered by unit testing. We use something called SonarQube to check if your code smells. That's what it's called. And it smells there, crappy code there. So you have to follow that. You have to have an automated and tested rollback, and some more. Some of these things are organizational-wise, something where a team promised to work in a specific way. Some of them are technical. But it allows automatic CAP approvals. So if your business service and your pipeline has been approved and has delivered this, proof of you're following these things, you just answer a checklist, then it's put a config file in a central repo, and then when you run your pipeline, it actually automatically approves production, as long as it can see that your dev and test has run successfully in the same release. So one pipeline releases, dev and test is successful, then it comes into production, and then it actually has an automatic approval. It only takes a few seconds. But it's still registered in ServiceNow, and it's still registered the same way as the other things. But it means that from a central place, we can put a release freeze and all these things, or put in new rules to check that. This is not owned by my team. When we do infrastructure CAP, it's kind of the same, but you don't need to do trunk-based development, for instance. It's simply if you have something that is pure infrastructure, such as an ARM template for Azure. Yeah. So, but what we do to kind of control all those regulations, one thing is this thing called the Cloud Security Framework. Microsoft has an example of this now, but we have, way before I started, in 2018, I started in 2020, 21. no, sorry, 20. They made this crowd security framework in Microsoft. It describes things of a security nature, what settings to set. It does not describe things like availability, recovery, all that. It only talks about securing your setup. And let me show you one of those. Now, first of all, actually, I'll switch that around because it feels better to show an example now. I know it's not super huge text, and I have cut it off right when our rules are there, so you can't see the actual rules. That I realized after preparing for conferences that showing the firewall rules for a bank might not be the best idea in a production setting, in public settings, so I cut that off. I have been approved to show this. This is an example. It says D7, control connectivity to CSP private, and the text says that if you have virtual private networks that are connected to the Saxo Bank and host IIS resources or VMs, anything that can be hosted on the VNet, then it has to follow these rules. And the rules, in the short, is that we want to have a firewall, of course, layer 3 filtering, source IP filtering. If it's HTTP, we want a web application firewall, for example, an app gateway. And then there's a few more things. But this does not describe that we should use an application gateway. It just describes that we need a WAF. And then based on, for example, in Kubernetes, the WAF is then Nginx instead of application gateway. A little fun fact is that application gateway is built on Nginx, so it's very much the same. But when do we have to use these? Well, we have a few which has not really been prioritized or implemented on Playground. In Playground, we would want to do stuff like make sure things are cleaned up that are not used, so that we don't use excess money. Make sure that you cannot peer to the production, and that one we have put in. In standard, it's like everything we have except these Playground, which is like completely outside. These are all the rules called S in the beginning, and these are for all production workloads. That could be things like collecting the activity log, any kind of Azure diagnostic setting. There are several things there. But there is also a category called DTAP for development, exception, test, and production. And this is where you can really see that this was not built by ourselves, because we don't have a acceptance environment. At least we don't call it that. And it doesn't work exactly like that. But this is kind of a standard thing where we can see that. And these are all the stuff that are connected. For example, the D7 I showed is from here, DTAP, D7, and everything we have in a normal dev, test, or prod have to follow those rules, which is, of course, sometimes challenging because some of the development, making a smooth development in a hardcore environment like that, it can be quite tricky. Advanced, well, sometimes we have PII data, and sometimes we have highly classified PII data, which is like, who do you vote for, or something like that. And if we have that, or even secrets from other banks, they might be marked as advanced. And here we would use stuff like extra rules about encryption keys. Maybe the bank, the partner wants to provide their key so that their data is encrypted with their key, and another customer with their own key. Bring your own key stuff like that, that kind of takes the extra level. Yeah, but how do we implement it? Well, our security controls is log analytics as a central place to save logs. We are using Azure Monitor to deploy, to alert things, and we are using Azure Logic apps. Sorry, it's not there actually. It's Azure Logic apps to trigger, let's say, integration to ServiceNow when there's an alert. But one thing you see here, which I haven't mentioned yet, is that we define the alerts in an Excel sheet, and then we generate it. We run a script that makes it into a JSON file, and then we deploy the JSON file. And everybody who's new on our team or never seen it before, they always come with the question, why don't we just change the JSON file? I mean, why do we have to do it in Excel? Well, there's two things for that. One is we don't make the Excel sheet ourselves, at least not, we don't own it. We help security define the alerts. So whenever there is audits, and there's probably audits every month or so, at least one a month for somewhere, they just give the auditors or talk with the auditors about the Excel sheet. They don't even call me or write an email, so I don't have to deal with all these auditors. And if there's one thing I would like is not to deal with any of these auditors, because that is sometimes some of the most boring meetings you can have. But they can also be quite fun. See if you can trick them a bit. That was just a joke. We never cheat. Anyway, this is an Excel sheet. We generate into JSON. JSON describes all the resources we need to make, and we deploy that with a pipeline. Azure Policies is where I want to show a bit of our new stuff that we have. We're using Azure Policies. In Azure Policy, you can either check things, or you can deny things, or you can make things happen, modify things. We mostly just check things. But we do have a few that blocks, and that is for tags. That you have to have a set of tags, who is the owner of the resource. We have a tag called Snow ID, which is like the connection to our asset. I'll get back to that in a second. But we also have connectivity. We block IP use in production so that you cannot make a VM with an IP directly connected, because we have blocked the connection between the VM and the public IP. Because we want all of the public IPs to be on the other side of our central firewall, of course. So you cannot make it. We also have to make sure that app gateways cannot have public listeners, because we want everything to go through. Yeah. And then we have Azure Automation runbooks, because while we can use policy for stuff, and we can also have resources send their logs, and we can do alerts, there are still things that we cannot do in policy. For that, we use runbooks in PowerShell, which executes from Azure Automation. But let me just do one thing, because I see that I had the wrong. Yeah. No, yeah, it actually, yeah, this one is correct. I'll get into a demo soon. The last thing we do here, at least what I'm going to cover today a bit about, is our service certification. Because you cannot just make any resource in our production. Well, if you're in Playground, you can do what you want. You can also get an MSDN and do what you want. But if you are connected to the network, then you need to use an approved template. So who makes those templates? Well, everybody does. The team itself. If you are a development team and you want to create a resource, what you do is you go to the repo of approved templates and you make a branch, and then you put your template in there. And then it's actually possible to use in dev. But if you want to use it in production, it has to go through an approval phase first. And it has to be, in technical terms, in dev you can use other branches than master. In production you can only use master. And therefore we can only allow things to come into master if security team has accepted the pull request. And my own team. So we do that by making ARM templates and put them in a central repo. And I'm just going to skip that and go to this picture, which is kind of files. I think maybe people would understand that better. So as you can see, we simply save them in a structure that resembles the resource providers. So that if you are to find a template for a specific resource provider, then you go through the folders and you figure out if there is one. And then we have multiple versions, such as version 1 here, version 2. Version 2 preview is something we do sometimes when we want something to come into production. So to be able to deploy it in production without the security approval. That could mean proof of concepts where they have an exception from security that allows them to not have it fully approved. But that's something we don't do that often. But you see the README here is the most important piece, because the README describes all of the rules, all of the settings that we make in a template, all of the limitations we have made, and all the reasons, and also all the controls that covers it. And this is what security approves. Security doesn't approve the template. They don't know about ARM templates. They should not be experts in ARM templates. They are security. They have lots of other things to think of. My team is expert in ARM templates. So before it gets to security, there is an architecture review where somebody from my team or myself goes in and reviews, is the README correct according to the template, and is the template built in best practices? Now, I'm not going to show ARM templates today, but I'm going to come to the first demo, because we don't allow anybody to run their own PowerShell against Azure. Isn't that great? So they can't do nothing. Well, yes, they can. The challenge here is if you are admin in Azure, you can do quite a lot with Azure PowerShell, right? And security is a bit scared of that. So we also have an approval process for scripts. Again, you can test it out in your playground. You can make sure it works in your own things. You can run things locally against your resources. But if you want to run it in a pipeline and thereby against production, because you will never get access to run PowerShell from your machine to a production resource, unless you have some kind of incident that is a big problem, like a P1 that customer is affected, no rules, let's fix it. Then we fix it, and then we make the pipelines afterwards. But and we note that for auditors, of course. But here we have the approved scripts, and if I go to my real machine, crossing fingers, internet is working fine. You see that if I go to our TFL, oh sorry, that's the wrong one, this one. And this is of course the one demo I forgot to open. But I'll open the repo for our approved scripts. Here you go. Same structure you see, for example, in Customers DB, we have a script. It's a bit small maybe, but we have a script to rotate connection strings and put them in a Kubernetes secret. So we can actually have this, because this has permissions to connect to the full resource group. They have full owner permissions of their own resource group. I'll get back to that. And they also have, They also have full permissions to their Kubernetes namespace. So we can do quite powerful things in these scripts because we control the output of the script. We make sure that nothing is locked. So we can generate secrets and put them into key vaults without anybody ever knowing what that secret was. We do that for production. So only systems know it, or if we have an incident, we can then break the glass and come in to the account. But then you can actually, when you run a pipeline, you can simply go and run a script. So let me just do that very quickly, but I'll have some more pipelines and I'll not spend too much time on this. I'll do it in the graphic ones. I'll get back to that also. Sorry. Yeah, so all it is that I can simply go and add, and then I go Azure PowerShell Cloud Factory. That was our old name. Azure PowerShell script. Now I cannot type a script here. I can only type a path that is relative in the approved scripts. And what you will see if you come to my session tomorrow about making these tasks is that this is simply stolen from the official one. You can download the code. I remove some lines, put in some lines that can only get scripts from one repo, completely standard, Git things. There's about 3 lines or so, and then we put it in here. So it is the official one. We simply have changed, but I'll talk about that tomorrow. Yeah, because I have some more about these tasks here, and I want to get to the real demo in the end, so you can see it all in one go. We allowed only certain set of tasks in our pipeline. We have custom tasks that we provide for users, which is creating a resource group. This is the one I'm going to show, which also does a bit more than that, you'll see. Approve scripts, Azure AD app registration, so that anybody can make app registrations, or deploy SQL database, or provide access to the SQL database. And this one is a package deployer. It's owned by another team, but it can deploy files to VMs and more. But we also only allow a set of tasks. We allow only our own tasks. That's great. And then Kubernetes tasks, app service deploy, app service manage, Azure resource group deployment. This is the one that deploys the templates, because we are deploying with the out-of-the-box task. Azure file blob, something with Databricks, PowerShell script, but not the Azure PowerShell one that has the correct permissions, as I showed before. But how do we control this? And this is the main demo I want to show, the whole flow in what we do so that we can control this. And of course, we also have options to whitelist specific tasks for specific projects if they have some kind of exception. To be honest, one of the worst things about working in this kind of environment is when you make a super nice technical limited setup and then they come from a direction see, hey, this project needs an exception, they can do it. This is kind of what Rob said when they had the COVID stuff, right? You can't work from home, now you can, please fix. The same here, right? We do all what we can so the people can work as free as they can. They don't need to contact anybody. They can do all the way to production almost without having anybody else involved. If they follow and know about these, what I'm talking about now. What we do is we have this create resource group / deployment prep task. And this is the task that I will show in a second how that works. It's a task that essentially creates the resource group, but it's a gate to apply rules. But we also enable temporary access. And this is what I'm going to show in a second. The thing is that the service connections that they have, the connections they use to deploy to Azure is not working. We simply typed in credentials that are not correct, something like dummy, whatever. They don't work. So they run it in a job, and I think I'll show that in a, I think I'll actually jump to, I think I'll jump to the demo actually, and then back to the slide, because I can see it will require too much explanation. I think it would be easier to understand like that. So, and actually that's not there. If I can show you here, there. And of course, I thought I opened all these before. Anyway, if you have a pipeline, how many has used DevOps before? Pipelines? Like half or a bit more. In a pipeline, you have what's called the agent job. That's these three you have. This is what I expand now, right? Agent job. This is run in one process on a machine. When that job is done, the process is shut down and next job could be taken by another agent. Now, when we open this job, the connection doesn't work, but we enable the connection. And then when the job is done, it's just forgotten again. So we give a temporary access for only those in this little job here, if anybody can actually, it's a bit slow here. Yeah. This is, I'll zoom out a bit again and then make it full screen. This one called set sample is a dev version of the task that I just mentioned. So this task will actually, when it's run, you define stuff like who is the owner. This is the owner app in our ServiceNow. And we define name of the resource group, and we define a service connection to use to our API, which is the function I'm going to show in a second. But we also have a connection to Azure, and this is the connection that doesn't work. It does not have any valid credentials. But if this is approved and okay, and what we do is actually to check the whole job and see what it's trying to execute. So let me go back to that slide there, because let me show you what we check, and I'll get back to the pipeline, of course. Yeah. What we do is we enable temporary access. One is to give a SaaS token that works for a few hours to our approved templates that can then be used later in the pipeline, but also Azure Resource Group development deployment, which is the normal deployment for templates and all that. The service connection becomes owner, but only for that one resource group that they made, and only for 2 hours. Actually, it's 10 minutes in the demo I'm going to do in a second. We check which task I use. We check the template. So if they use the deploy template task, we actually open the template, we pass the template, we make sure they don't have any resources that we don't allow. We make sure that any templates that they try to deploy inside the template as a linked template are from our approved repo and are from the correct branch. We also check in production if a change request is actually open or not. And this is where, in production, we check that it's only master branch that has been used. So we have this task to enable the access, enable the connection, but also to do a lot of checks. And we can then make special rules for certain projects. One little lesson learned, and one thing to take on with you is always make sure you can do exceptions. This will come at some point. So what happens when we deploy one of these is you run the pipeline, it creates the runs the create resource group, which calls our Saxo Bank self-service API, as we call it. The Saxo self-service API then connects to ServiceNow, and it takes that little ID that you sent, and it makes sure that it exists, what's called the Cloud App ID, exists in ServiceNow. But because it's in ServiceNow, it can also get extra data like who is the owner, what is the cost center, what is the business service, and all the things you want as tags. But the user only defined one thing, and using the call from our API to ServiceNow, we can then validate it's correct. We can validate that they have an open cost center. We can make sure the cost center is not blocked or anything like that. And then we can return all of the fields we want. And then when the organization comes in half a year and say, hey, now we changed the whole organization, they did that half a year ago, then we suddenly need to send other data back. And then we just change the function in ServiceNow, and it then sends other tags back to the resource. So it's actually super flexible for us to add new. So now the self-service API has been validated, so it calls Azure and it creates the resource groups with the correct tags. And then it sends back the temporary access tokens, and the pipeline sets its connection credentials so that it works. And then you can run whatever out-of-the-box task we allow. We don't have to make custom tasks for everything, because we use that service connection thing as kind of the gate, if you have permissions or not. So nothing, there is no, of course there is an extra secure project for bootstrapping Azure, which is in a different place, but otherwise there are no service connections to Azure that actually works, so unless you go through this. Deploy template, Azure gets the approved template from a storage account, which is where we host them, sends back the template, Azure deploys the resources. This is a normal flow for a dev pipeline. Yeah. But if we look at that, and I'll, sorry, wrong one. So if I go back to the demo here and we look at the sample here, the sample is, I'm going to explain tomorrow why it's called that, why we are deploying a test version and a production version, but this is the test version, and in short, we simply have a test version that we can update anytime and test in production before we do the last step and actually replace the task that other people are using. This one is where we have an inline script, Azure PowerShell script. In this sample version, I have not added all of those checks inside the templates, all of that complex code. I don't have a call to ServiceNow. I kind of simulate that, but it still works in enabling the connection. That's kind of the main purpose of this. So we run this. It calls our Azure function here, which I can open. Oh, I have it right here. Here. Calls this Azure function. I'll get back to that in a second. It's too many. I have too many windows in this one. This one, yeah. It calls that, and this means that if I try to run a PowerShell script before it happens, it will fail. Then it gets this, and this one will then update this service connection, and then we can actually run the resource group. So maybe we should just trigger that. And yes, they can also be used in YAML. There are not much differences. I'll talk a bit about that tomorrow. What one thing that you want to avoid if you want to support YAML too. And another thing in this task is that you have really nice ways to kind of make a GUI that is flexible, right? So for example, the app, something like that. We can have regex and stuff like that to check it. Again, I'm going to explain all that in the session tomorrow. So if this is queued now, and while it's queuing, I'm just going to open the function in the portal too. How many were in the Azure Functions session before this? How many went here because I promoted the session? Or did you already know? Okay, phew. So it worked. Thank you for coming. It's simply an Azure function. I'm not going to go into details about how this Azure functions is set up here. You can watch Barbara's session about how it's basically set up with security and all that. One thing I don't know if you covered, because I was running around finding all my stuff, is that we are using an authentication here, what they usually used to call easy auth, but it was super hard to do sometimes. So it's the most, it's like a year standing joke about, it's easy. Why do we spend 1 week trying to figure out this problem with easy auth, right? 10th meeting, troubleshooting easy auth. So they probably got too much feedback on calling it easy. Now it's just authentication. It means that we can make a PowerShell function that does not care about any kind of authentication. It's a very simple function. The first part here is simply the base example, except I put in the preference here, where you read the inputs that we can send. Body, where we send what's called the owner ID and owner project, and we send the name of the resource group, and we send the ID, which is that Snow ID reference to our asset management. And then I'll just get back to that in a second, then we select the subscription, and then we can actually simply run Azure new resource group. And this is some code I will share. Oh, shit. The task itself, the code, I'm also going to share. I cannot share the APIs we're using. They are super bloated with 1 million lines of C# and all these things, so you would not want them anyway. But this is kind of a simplified version of it, where we go and kind of ask ServiceNow, but I just made some hash tables here. We see with the app and the CI name, owner. This is the data we would get from our ITSM system or asset management. And then we simply add that to a tag, set up tags here. And then we actually take the inputs and this is interesting because we send the ID of the pipeline and we send the project. And using those two, we can kind of mark this resource group as owned by that pipeline. So this means that in our production version, if the owner pipeline tag doesn't fit with the pipeline that tries to deploy, it's going to say, nope, it doesn't work. Because if that was the case, then any team could simply make a new pipeline with the same resource group name and then override the other teams. So we put in tags which pipeline owns it, which pipeline deployed it. And if we need to change that, then they know to contact us in a chat or in an email to our incident system, and then we remove the tag, and then it's free to claim again. Anybody can deploy, and then we put it again next time they deploy. So this is working really well also with app registrations, so that we know exactly that pipeline was the one deploying it and creating it, and therefore it's only that pipeline that can change it. There are some use cases where that becomes a bit cumbersome, but it's pretty good, I would say. We can then make the resource group, we can read the resource ID of the resource group. But then I added some standard Azure code to go and say, does this resource group already have an app registration or service principal in Azure? Check that. If it doesn't have an app, then create it. Create an app. And then look for the service principal for that app. Because the service principal is kind of the instance of the app in your tenant. I'm not going to go into Azure AD discussion because I will either spend 45 minutes or blow your mind completely and you don't know what is up and down. But what we do here, we create a service principal from that app and we define it to only have owner access to that resource group we just created. And then we go and create, in this case, a 10-minute certificate for it to authenticate. But this is up to you. I think we use 2 hours in our setup. Of course, the job has to be done before that runs out. And then I add these new secrets to the output, and I send back in the body, I send back the information from the resource group and also these client ID. And this function here is called by the task. And if I open the task, which is also here, you'll see that here. This is, of course, what I'm going to share. You see that we am going to go into more details tomorrow about the whole structure of this, about it uses a base module and stuff. But what we do is we simply get an access token, which is the service connection, and then we call it, as you can see here, the body. We post the body to our function. And then from the response here, you see it checks what tags came back and what the resource ID of the resource group were. Actually, that would make more sense if we put that first, right? Should always optimize a bit while you present, right? Because you would want the resource ID before the tags, otherwise it would probably look a bit weird. And then you break your whole code. There you go. But you see what's interesting, if you haven't seen it before, at least, let me just put that there. This little right host here is a way to set variables in pipelines. This means if I run this as an output, this variable will be available later in the pipeline. So I can output the resource ID so that if any jobs, any task after that actually would, it actually will work. But I don't only have 4 minutes left here, so I'm actually almost done. What we do here is to simply receive those secrets, right? Then we make what's called a credential object here, PS credential object. And then we simply use connect AC account to retry until it works. Because trust me, it won't work straight away. It takes around 30 seconds before it's kind of synchronized. So by doing this in this task, by making sure in a repeated fashion that it's actually working, then we can return it. And this is interesting because those 2 lines here on 88 and 89 is outputting a very special syntax here where it says set endpoint. This is built in DevOps. Endpoint ID is the service connection we chose. And the key service principal ID, we then send the key. So these 2 lines is a built-in way in Azure DevOps to update a service connection in this session or this job. So after these 2 lines, now the connection works. And now it can go to the next step. And as you can see here, it ran while I was speaking. The first one failed. These are 2 of the exact same Azure PowerShell task before and after. The first one fails because it doesn't have a connection. Mark. Then it runs here for 1 minute, and then it tries again, and then it works. But let's see what it outputted. Hey, it outputted only the same resource group as it deployed. What if you want to deploy multiple resource group? Then you just make multiples of these tasks, and you will probably do that in separate jobs anyway. And you would make one for one resource group, deploy the content for that resource group, another job below it for the next one, or multiple stages. I mean, we have things with over 50 stages in them sometimes. But this kind of is what we do. So the last thing I have here is to kind of say the full flow of our stuff. And I'll make sure eventually, as Rob said, to put it on the GitHub. It will not be today because I also have the task version tomorrow where I'm probably going to do more fixes live and then we can put it on. But when we do a production release, as I say, we create the change using a task that the DevOps team has made. And we define what is our business service that we deploy this to. And then if we are CAP approved, low risk CAP approved, their service will call back to our actual pipeline. Which I'm actually going to show a real pipeline here. This one, we have some sample. I think I can show a sample pipeline, right? Production pipeline, edit. I just want to show you that this is the change in ServiceNow task. We define the actual business service. And then we put in on a serverless job, we put in a wait for ServiceNow. This simply waits until either somebody clicks the button or the automation clicks the button. So ServiceNow service, the one they created, calls back to the pipeline and actually clicks this manual intervention when it's ready. And then we mark it as in progress, and then we start running our task, which has the actual resource group enable, and then also we deploy the standard ARM templates. And let me just show you the rest of the flow there, because it's then creating that change, waiting for CAP approval. And then we run the create resource group task. We send the cloud ID to ServiceNow, validate it, returns the tags, updates the resource group or creates it, sends back the tokens. I mean, the rest here is the same as the So you just copy the dev stage and put the other things in there. I say just, because this is very difficult if you don't know how to do it. So we try to give good examples for teams. And then when we have deployed it and get it approval templates and they are deployed, then we can actually go back and mark the change request failed or completed. And to deploy one of these pipelines, I would think the wait for CAP approval step, if it's low-risk CAP, is about 10 seconds or so, sometimes a bit more. So it's not something that takes very long. But it makes sure that we have all of the things audited in our ServiceNow in changes. Yeah. All right. So let me just see if I think I have everything for now at least. The standard situation happened with me where I have lots of ideas and then the time is not there exactly. The only thing I would like to just show here before we stop is, let's see. Yeah, the CIs here, we define what's called a cloud app in here where we define these owner and other things. How many are using business services here in ServiceNow or anything like that? No one? Lucky you. The thing is, one lesson learned I just wanted to mention is that this is the mistake everybody does. I have been in more than 15 companies as a consultant where this happened. We make a business service and then we deploy something. Suddenly they have 4,000 different business services and nobody knows what is what. So we are moving away from business services into something called the CSDM model, because we also have way too much customization, and that is the enemy. If you can avoid it, it's good to avoid. We're migrating to something called the CSDM, which describes application services, databases, and all these things, so that we can not overuse business services for any kind of thing you would imagine. Yeah. That's about it. So now we don't have 15 minutes. We have exactly 0 minutes for questions, but I'll be here at least until tomorrow evening. I have to leave before the party there. But thank you for coming, and I hope to see you tomorrow.